Remember, you guys can use your notes on Socratic. Log in, work on Socratic, please. Remember, y'all can work on your notes for Socratic. Alright, write down your homework, start working on Socratic.
What's your thought?
I've noticed one Indian or like Asian person like word.
Warning.
No, there hasn't been.
So your notes are taken. My dad just went.
You gotta answer that for yourself.
Let's see. I should not pass.
Where? She threw it over the fence twice, but she backed up. There weren't cars. There weren't cars. Because I told her she would see the car. And then I stopped. But yeah. I mean, we were able to do it. Huh?
Homework written down, start working on Socratic.
So, okay, my Wi-Fi is.
Remember, you can use your notes.
Yeah. But it's probably the only one else to do it. And then, but not like
kind of stopped me in the middle of my name and accidentally.
That's okay.
pressed
As long as I can tell who it is. Madison, you finish? Just keep the short position.
gosh, it must be Jerry.
Connor, finish yours correct. All right, close up your laptops. Let's go over it. Then we'll talk about what we're doing today. So, what has mass and takes up space, Sophia?
Matter.
Matter. Very good. Matter has mass and takes up space. What is a phase of matter that has a definite shape and a definite volume, Jared?
Oh,
Definite shape?
oh.
Solids. Solids. Remember, solids have a definite shape. They don't change. Liquids take the shape of their container. Okay? What phase of matter has no definite shape but a definite volume, Tyler?
Liquids.
Liquids. Very good. They have no definite shape. They take the shape of whatever container that they're in. What phase of matter has no shape and no volume, Madison? Jenny? Gases. Very good. Gases. The amount of matter per unit volume is known as what, Mr. Squire? Density. Very good. Okay. Remember, chemistry is the study of matter. Okay. 4 basic properties of matter, Callum. B. Mass, volume, weight, and density. Okay. Are these physical properties or are they chemical properties, Callum? What do you think?
Physical.
Physical. They're things we can see, things we can measure. Okay. They don't determine the chemical makeup of the substance. True or false, crystallization is one of the 4 phase changes, Olivia? False. False. Remember, 4 phase changes: melting, freezing, evaporation, condensation. Scientists who study matter are known as what, Julia? D. Chemists. Good. Chemists. 3 phases of matter, and how do we describe each phase? So, 3 phases of matter: solid, liquid, gas. We describe each phase. Solids have a definite shape and a definite volume. Liquids have no shape but a definite volume. And gases have no definite shape, no definite volume. Okay? We're all so excited. Which of the following is an example of a chemical change? Madison Recorder?
Burning wood.
Chemical change, burning wood. Very good. Remember, melting wax, melting, looking at the verb, that's just a phase change. Okay, it's going from a solid to a liquid. Evaporating water, again, a phase change, going from a liquid to a gas. Okay? Phase changes are physical changes. They are not chemical changes. Color, shape, and smell are examples of chemical properties. Sophia?
False.
False. They are physical properties. Which of the following is an example of a physical change? Jared?
A.
A. What physical change?
Ice melting.
Ice melting. Good. If you're burning something, remember, you're changing it chemically. It's no longer that substance anymore. If you burn a log, you can't make it a log again. Okay? If you melt ice, you can freeze it again to make it ice again. Okay? An example of a physical and chemical change. Example of a physical change: tearing a piece of paper, any type of phase change, evaporating, melting. Chemical change would be anything set on fire. Okay? Oxidation, rusting, anything along those lines. Remember, these 2 short answer questions you're going to see again on your test. Make sure you're using these as practice for your short answer questions on the test. Okay? All matter is made up of what, Mr. Squire?
Elements.
Elements. Very good. Elements. Elements are arranged on the modern periodic table by their what? Madison Denny? By their A, their atomic number. Their atomic number. Columns on the periodic table, the up and down ones, they are known as what? Tyler?
Periods.
Up and down?
Groups.
Groups. Good. Periods are left to right, they're in rows. Columns are up and down, those are groups. Rows on the periodic table are known as what? Olivia? Periods. Very good. Okay, remember, groups are up and down, left and right is the direction that they go. Okay? Groups are up and down because they're columns, periods are left and right. The word periodic means what, Callum?
Repeating pattern.
Repeating pattern. Good. The first letter of a chemical symbol is always capitalized. Madison McWhorter?
Sure.
True. It is always capitalized. A material that can be hammered into different shapes is known as what? Juliana? C. Malleable. Very good. Ductile means it can be pulled into wires. We can make it into wires. That's ductile. The first scientist to create a periodic table was who? Sophia?
B.
D. Mendeleev. Mendeleev. Good. And the second to last one? Yeah. One key feature of nonmetals is they are what, Jared?
Brittle.
Brittle. They're brittle. Okay. And the last one, which of the following is not an inert gas? Connor?
Oh, okay. I was going to ask you a question about this because I didn't see the knot in it. It's oxygen.
Oxygen.
I picked neon.
Oxygen. Oxygen is the only one that is not an inert gas.
I didn't see
Okay.
the knot.
You gotta make sure you read the entire question. We'll talk about these today, but remember, you should have been able to see in your notes all of the inert gases. All right, let's open up our books. Let's get into section 9. This is our last section before the test. We'll review tomorrow, and we will we'll review to do our challenges tomorrow. Review on Friday, and we will take our test on Monday. All right? Any questions about anything we have coming up? Okay, at the end of class, because this isn't a very long section, what we're going to do is we're going to practice those first 20 elements again. You guys are going to come up, we'll do the challenge, the race to find the first 20 elements like we did yesterday, a couple of days ago. Only this time we'll actually record times, see who gets the fastest, and we'll be seeding everybody into a bracket for March Madness for a tournament that we'll have on Friday. All right?
This class?
This class.
Can you repeat that? I wasn't listening.
So, basically,
Teacher?
yeah.
Thanks. So, what we're going to do is everybody's going to come up and do the first 20 elements. We're going to see who gets the fastest time. We're going to rank the fastest time, and just like March Madness, we're going to have brackets and everyone's going to challenge each other. We'll go across.
You
seasons.
can't go though, you're not involved in this.
Hmm?
You can't go, because you're gonna get like
I'm not
5
going.
seconds.
I'm not going. March Madness is the college basketball tournament.
You're like pro NBA when it comes to this.
So,
You're like college.
all right, let's read about the inert gases. Jared, first paragraph, please.
Look at group 18 of the periodic table. What do the elements in group 18 have in common? All the elements in group 18 are gases. They are called the inert gases. Inert gases are sometimes called the noble gases. The word inert means inactive. The inert gases are not chemically active. They do not combine readily with the other elements in the chemical reaction.
Good. All right, what notes do you have? Juliana?
Elements that make up the last group in the periodic table then.
Okay, so there are 6 groups that make up the last column of the periodic table.
chemically active.
They're not chemically active. Connor?
The word inert means inactive.
Inert means inactive. Good. Alan, do you have one, or they get yours? Anybody have anything else? Okay, so the last column on the periodic table, those are the noble gases, or the inert gases. Okay, the reason why they're called that is because they don't react well with other things. They don't combine with other things, and they just kind of sit there. They just kind of chill out. They don't really do anything. They don't combine with others. They don't play well with others. They're the ones that sit off by themselves and read books. Okay, they like to watch Netflix. They just don't want to go out and hang out with other people. They just like hanging out by themselves. Okay? We're going to talk more about them in Unit 14, talking a little bit more about why they're inactive. Okay? Talk about more about their electrons and the atoms that make them up. But this is just kind of a preview that these are the ones, they're inactive, they don't react with others. We can still use them for stuff, but we don't use them in chemical reactions like we would use water or chlorine or some of those others excuse me, that we have on the periodic table. So just to show you where they are, so we can see that right here.
Can we have like a practice round, and then we do like the time?
We're not going to worry about that until we get there.
9.
Okay? So, these 6 elements right here are your noble gases. Okay? Alright, let's continue our reading. Common inert gases. Count.
The names of some of the inert gases may be familiar to you. You probably have heard of helium and neon. The names and chemical symbols of the 6 inert gases are listed in Table 1. All the inert gases are found in small amounts in the Earth's atmosphere. The most common inert gas is argon.
Argon.
Argon makes up about 1% of the atmosphere.
Okay? What notes do you have? What notes did you take? Cal?
They arrange the elements by atomic number. Oh wait. Oh, I was in 12.7. That's why.
Let's go down to 12.8.
Yep. There are 6 common gases.
Okay, there are 6 of them. Madison?
All the inert gases are found in small amounts.
Good. All are found in the atmosphere. Okay, Sophia?
The most common one is argon.
Good. The most common is argon. Any others? All right. Connor?
Argon makes up about 1% of the atmosphere.
We can put that in parentheses. That is about 1% of the atmosphere.
I listed all of them.
You listed all the inert gas, or all the...
Yeah, like, for example.
Okay, so you could say example, name the inert gases. Okay.
Helium, neon, argon, krypton,
Krypton,
X,
xenon,
xenon, and radon.
radon. Okay? Good. You can do that. Since they're all right there, you can just mark them down right there. Not a big deal at all. Okay? So inert gases are everywhere. We use inert gases, not maybe in our everyday lives, but you breathe in as part of air. So you breathe it in every day. And remember, the stuff we breathe in is not pure oxygen. Pure oxygen is overall not very good for humans. Okay? We have to breathe in air, which is a combination of chemicals, and one of those chemicals is argon. Okay? Well, now let's talk about what are some other uses that we have for these inert gases. So let's see. Connor, go ahead.
Wait, I just,
Do you have a question? What?
why is oxygen bad for you?
It's not bad for you. It can just become toxic because your body, if you're breathing in pure oxygen, your body just can't process it all.
Because it's like overloading your body. The the inert gases have important uses. You may have heard of neon lights. Neon is used for lighting because it gives off a bright red light. When electricity passes through it, by mixing neon with different gases, many colors can be produced. Many of the signs that light up theaters, restaurants, or businesses are neon lights. Argon and krypton also are used for lighting, sorry.
That's okay.
They keep ordinary light bulbs from burning out. Helium is used to fill balloons and airships. Xenon
Then the X is a Z.
xenon
Okay.
is used to photographic lamps. Radon is radioactive. It is used to treat cancer.
Okay.
So it's like, what's that treatment called?
Chemotherapy.
Yeah.
It can be used as part of chemotherapy. All right. What do you got?
I just named
They all have important uses.
Okay.
Like
All have important uses.
neon lights.
Okay. Then we can get specific. We could say neon is used in lights. What else?
That
Connor?
thing that was used.
Connor?
Argon and krypton also are used for lighting.
They're more light bulbs than lighting in general. Light bulbs. Okay.
Radon is also used to treat cancer,
Radon to treat cancer.
which is radioactive.
Okay. I'll say that. Radioactive. Olivia, do another one?
No.
Okay. We're missing one. We're
Xenon.
missing two actually. Xenon? What's
It's
xenon?
used to use in photographic lamps.
Good. Photographic lamps.
Helium.
And the last one is helium. What do we use helium for?
Or balloons and airships.
For balloons. Good. Very good. Okay, so you see these things, we use them all the time. Argon and krypton you don't really see, they're in light bulbs. Okay, radon is used to treat cancer. Helium, of course, we use to fill up balloons. All right, let's compare our notes to the notes we have over here. See how we did. Okay. First one. 6th group, group 18, called the inert gases. Inert means inactive, do not combine with other elements. Good. Probably add group 18. Misworded here. Instead of 6 groups, you could say 6 elements instead of groups so it doesn't get confusing. And then found in group 18. Okay, see what we did there? If you said 6 groups, that just makes it seem like you're talking about group 6, which is a totally different group of elements. Second one, common inert gases found in small amounts in the atmosphere. Example of argon, we got more than that, which is good, because it's 1% of the atmosphere, and the example listing them all out. And the last one, uses of inert gases, neon lights, argon, krypton, radon cancer treatments, xenon lamps, helium balloons. Good. All right, close up your laptops.
Oh god.
I like shut it off.
Okay, we're going to go over this first. We're going to review what all these elements are. Remember, up on my website, I have made a Quizlet on the homework page of my website with the first 20 elements on it. Use that to practice. Okay? We're gonna go through this, see if you can name them. H.
Helium.
Hydrogen.
Hydrogen. Hydrogen. H-E.
Helium.
Helium. Good.
Lithium.
Lithium. Very good. Lithium. B-E.
Bethan.
It's a tough one.
Bengal.
Bethanol.
No.
B.
Beryllium. 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 Regular B?
Boron.
Boron.
Yes.
Good. Boring old boron.
Carbon.
C?
Carbon.
Carbon. Wait till I get there before you yell it out. And?
Nitrogen.
Nitrogen.
Oxygen.
Fluorine.
Fluorine. Very good.
Neon.
Neon. Okay. And A?
Salt. No,
Not
sodium.
salt. Remember, salt is a compound.
Sodium.
Sodium by itself. Sodium. Mg?
Magnesium.
Magnesium. Very good, Jared.
Aluminum.
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 Cyclone.
Silicon.
It's a valley in California.
Silicon.
What is it?
Silicon.
Silicon. Very good. P?
Potassium.
Not potassium.
Petroleum. Petroleum, yeah.
No. Petroleum compound. Phosphorus.
What the?
Phosphorus. S?
I don't know. I don't
It's-
honestly.
it's-
Gives you that rotten egg smell.
Cycle. Oh, no.
Sorry.
Sulfur.
Sulfur. Sulfur. Rotten egg smell gives you sulfur. Cl? Chlorine.
Argon.
Argon. Last two. K?
Kryptonite.
Kryptonite.
Not krypton.
Sodium.
It's from a
Potassium.
Latin root, so it doesn't start with a K. It starts with a P.
Potassium.
Potassium. Very good. And Ca?
Calcium.
Calcium.
I did not
Calcium.
honestly know K. At
Okay?
all.
So, just for your reference, so you know, these are the ones you have to know. Everything above that red line is what you need to know. Okay? All the ones underneath, you don't have to worry about. Okay? You don't have to worry about them. The only ones you have to worry about are above this red line, those first 20 that we just went over. Okay? Alright, now here's what's going to happen in preparation for our periodic table March Madness. Okay? You're going to come up, everybody's going to get one chance to go through. There is no helping, there is no yelling out, there is no talking while the other person is going. As you go, you're going to get your time. Okay? I'm then going to rank all those times, and then I'll put them into a bracket for Friday. Okay? Now, to prevent this, okay? Every time you miss one, I'm going to add a second to your time.
That's so unfair. Why can't you just tell us not to do that?
Because
Then
that
you're
will
gonna do
prevent
it.
you from doing it.
No.
Okay?
No, I'm saying like, why if we actually missed one?
If you actually miss one, you'll still get one.
Okay.
You'll still get a
You can
second
say
added.
second, though, it's fine.
Only a second.
So we're doing
Okay.
like seeds. You'll have
So you're going to create your own seed time. Okay?
Wait a minute, so if you get like
Wait,
really
what's
bad,
K
you'll play
again?
lower seeds.
Wait, if
Who
it-
who else gets
wait.
really bad?
Miss
You'll play, it'll go just like anybody else. So,
Yeah.
listen, because you may be asking your question. So if you get the top seed, you're going to be the first one against the lower seed.
Okay, I see what you mean.
Okay? So it'll go 1 versus 10,
9.
2 versus 9, stuff like that. Yeah?
During the actual tournament, will it still have a second if we miss one?
Yes.
Okay.
Okay?
Never mind.
Okay? All right. Anybody want to volunteer to go first?
Why don't we
Cal?
just like go?
No.
Callum's first. Hang on, I got to write.
Callum, just think about it like this. No matter how bad or how good you do, you're
Alright.
still going to be number one.
Yeah.
All right. Ready? Let's start. Good? Good? Good?
Oh, what? Ah, dang it.
There you go. Nice job.
That's pretty good.
So, you missed one. Your time was 13.62, so your overall time is 14.62. All right, who's next?
Not me.
All right, we're going to start going in a row. Jared, you're up.
Yes.
Jared, you're up.
That's pretty bad for me because I don't pressure.
Did just fine. That's a great time. Got to start. Good? Good job. 24.21, so your total time is 25.21.
I'll go
Good
next.
job. Sophia? Oh, who said they go next?
Okay.
Alright,
If Sophia wants to go, okay.
then you, Connor.
I'll walk it on.
Alright. Latin root. Different Latin root. Good. Other Latin root. Nope.
This one's hard.
Good.
No.
Good. You're adding 4
No,
seconds, so
Kenneth.
you're at 28.46.
What?
Good.
No timid.
Connor?
No kidding. Future.
Wait, I have a question.
Yes.
Oh, God.
Hang on. What's the question?
So sodium is Latin?
Sodium has a Latin root, Na is its symbol. Okay?
Gary, you done last time.
Good. Good. Nope.
I know.
Good. Nope. Good.
Argon. Oh, God.
Nope.
I don't know.
Very good.
I thought I could have done
19.99.
better than
So you
that.
have 22.99. Very good. Tyler?
Almost 23.
Hang on. Your camera now. Connor, go sit down.
Wait, when's the tournament?
Friday. Potassium? No.
Are we doing this every day?
We will do this every
Potassium.
Latin root. No.
What's the Latin root?
No. Don't just guess.
TikTok.
Wait, what just happened?
No.
Oh, that's unfair. Oh, there we go.
No. Good.
Sound rolls.
Good. Good.
You got the right time.
Very good.
Yeah, Tyler.
That's fine, Tyler.
36.
This thing took off at least 3 seconds.
And I didn't count off one of the ones you tapped twice, so you'll be alright. Alright, Madison? Come on,
That's
you're up.
unfair.
Tyler, if I can first.
Connor, sit down, please.
Sorry.
Which, make sure you put the right Madison. There you go.
Good. Good. No. Good. Good. Very good. So with 2 errors, 24.59. Very good. Olivia? No. Good. 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 No. Good. Excellent job. 14.31 gives you a total time of 16.31.
She's doing first.
Juliana? No. Good. 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 Good.
Oh, jeez.
Very good.
Oh.
13.51 with 2
I'm still
errors
first.
goes to
Callum's still in first.
15.51.
Because she missed one.
Callum is still in the lead. Madison McWhorter?
She's 2.
Yeah, but she got better time.
Callum, you're hanging on
So
by a
that's where
thread.
she's gonna
No,
beat
she
you.
didn't.
Was because I missed.
He had 14 points.
Good.
That wasn't my original time.
Good.
So what was
Yeah.
your original time?
And
She still would have beat you.
That was just.
you asked about this one.
I know, I clicked that.
Different Latin root.
TikTok, TikTok, TikTok.
There you go. Good. Very good.
Awful.
Faucet.
33.29. Alright.
Can I try to go again? to get a better
Wait,
time.
Alright, so I will rank these. I'll have these for you tomorrow, all ranked up. And it looks like our top seed is going to be Callum. And lucky seed spot number 1.
Who's the last
Since
one?
Lily's not here, we'll give her the last seed, unless we have time. All right, how about your trapper? So I can come around and sign you off.
On number 3,
All right. Once I sign you off, we'll be good to go.
I think
I'm still blaming that red bar.
Remember, just like in the real March Madness, this could have no bearing on who the actual winner is.
Anything can happen.
Tyler, you could win.
Anything could happen.
Who thinks Tyler's gonna win?
Me.
Oh wait, I'm
Alex
not
thinks he's
last.
gonna win.
What?
I thought I was last. I was last.
No, that red bar in the middle, Mr. Buckley. You should let me go again. That red bar is something wrong.
yeah, I think
Oh,
Oh,
stop
no.
whining.
Wait, can I let me go again, but it's not gonna count?
Man, Jared